All right, so if you had a chance to work on that assignment last night, what you actually did is a large chunk of this was stuff that you used as you had gone through. A couple of these are going to be new properties, but today's focus is going to be on properties of the definite integral. For instance, we learned that if I took an integral from a to a, if you just think about that, if I were to give you a curve, and I wanted to know what is the area from 5 to 5 of that f of x dx, well, if I go from 5 over to 5, we would not have a rectangle. We would have simply a line. And we know that a line has a width of 0. So if we do length, height times base, that height would be whatever this f of x would be, but that base width, that delta x, would be 0. Therefore, if the limits of integration are the same thing, our integral will always be 0. You also learned that if the limits of integration are flipped, b minus a, from b to a, one of the things we can do is we could actually evaluate that integral of f of x dx from a to b, and we would just take a negative value. Because remember that dx comes from that delta x. So if I went from 5 to, say, 7, if I wanted to take the integral from 7 to 5, our change in x would be a negative value. And remember that integrals, unlike area, can be negative. The one we're probably going to use the most, in fact, if you want to put a star next to that one, we like that one. They usually test this one at least once somewhere. There's going to be a problem where they're going to ask about a random integral, and they'll flip one of the limits just to see if you're paying attention. But the one that we're going to use the most is probably this constant multiple. Much like the limit, we can take that constant here, k, and I can actually factor that outside of my integral. And while that won't seem like it's necessarily impressive right now, I will promise that later down the road it will be a very useful rule. Another couple things, if we have a c value that lays between a and b, then the integral from a to b of f of x dx, we can actually cut it into pieces, and we can say, well, we would go from a to c of f of x dx plus the integral from c to b f of x dx. And all that says is that we can cut an integral down into several smaller things. And last but not least, if I have an integral of a sum or difference, I can actually take this integral and I can go ahead and we find out that the integral of a sum or difference is the sum or difference of the individual integrals. I would like to note, just like in derivatives, there is no product value like that. The product rule actually is not going to exist. It's going to be taken up into things called U substitution, which is something that we're going to talk about that connects chain rule. And U substitution product rule is actually going to be covered in something called integration by parts, which is the calculus 2 topic. So the antiderivative, or the reverse of the product rule, is actually a little more difficult than we would anticipate. Also, the quotient rule is not going to necessarily have anything that we can exist. In fact, we don't really have a quotient rule for this. It would fall under that integration by parts, which again is a calculus 2 topic. So good news, we don't have to actually deal with those ever in this class. We'll have to manipulate things, but we're not going to have to deal with questions quite like those. So here's an example of the use of rules and the type of question that they may ask you. They might give you a question like this. If I give you that the integral from 0 to 3 of f of x dx equals 4, and the integral from 3 to 7 of f of x dx is negative 1, we want to find the integral from 0 to 7 of f of x dx. Well, with the information given, I don't know from 0 to 7, but one of the things I can do is I can break this into the integrals I don't know. So if you observe how this is written, if I go from 0 to 3, and then from 3 to 7, that's the same thing as going from 0 to 7 of f of x. So I can split my integral, which is going to be 4 minus 1 to give me 3. It's nice and simple. Just take the integral, split it up, call it a day. If I were to give you the integral from 3 to 7 of 2f of x, that constant multiple is where we would come in. We would take that 2 and factor that out. At this point, we know what the integral from 3 to 7 is. That is -1. And we say that our answer is -2. So these are all fairly quick, easy things. And my favorite, integral from 5 to 5 of f of x dx. These are the same. I'm not even going to show any work there. It's just 0. Ooh. So here's my fun one. Integral from 0 to 3 of f of x plus 4 dx. So the first thing I want to do is I want to split this. 0 to 3 of f of x dx plus the integral from 0 to 3 of 4 dx. Well, I know what the integral from 0 to 3 of f of x dx is. That's stated up here. That is 4. So this is 4. Now, if we take a look at this, if f of x is 4, then we have a horizontal line. Do it in a slightly different color there. F of x is 4. I'm going to want to look at that from 0 to 3, which creates a rectangle, height of 4, change to 3. So that will give us 4 times 3, which is 4 plus 12. Integral is 16. E is another monster. I see that 1/2. I'm like, oh, I don't like that 1/2. So let me go ahead and factor that out. And this is where someone may make a mistake. Someone's going to look at this, go, oh, the integral from 0 to 7, and they're going to say that the answer is 3. This is where you would get it wrong, because if you notice, this is not the integral from 0 to 7. This is the integral from 7 to 0. Our integral actually went backwards. So what I can do is I can take the opposite of my integral from 0 to 7. We know that integral is 3, so negative 1/2 times 3 is negative 3/2. And last but certainly not least, in this problem, take the integral from 0 to 7 of f of x dx minus the integral from 0 to 7 of 2 dx. And using a similar logic to the problem above, the integral from 0 to 7 of f of x dx is 3 from question A. This would be very similar to this, except we'd have a horizontal line at 2 with a distance of 7. This would be 2 times 7, or 3 minus 14. This would give us a net answer of negative 11. All right. Flip over to the next side. Next thing I want to talk about are odd and even functions real fast, something that maybe you'd recall from pre-calculus. Odd and even functions are going to be really useful in terms of symmetry. There will be questions that will come along with it. I will tell you, if you could draw the picture of the problem, that is typically going to save you a lot of heartache and headache. So if a function f is even, then f has y-axis symmetry. So if we think about that, anything that is a parabola, any parabola that has a vertex on the x-axis is an even function. So if I have a function that's even, and if I want to find the area between negative a and a, one of the things we should realize is that this side and this side have an even integral. So all I really need to do, and the reason why this becomes really useful is because you got y-axis symmetry. What we're going to find out later on is that starting from 0 is going to make this really easy. From negative a to a, f of x dx could be rewritten as double the integral from 0 to a of f of x dx. And again, I realize that that doesn't seem like a great move, and sadly we're not going to get into why that's a good move until later this month, beginning of next month, when we start actually taking antiderivatives and learning about something called the fundamental theorem of calculus. But when we get there, one of the things we're going to have to do eventually is we're going to actually undo a derivative, and we're going to substitute in a number for that. And 0 happens to be a lovely value that everything cancels out and everything goes away, and we like that a lot because it makes it so that we don't mess up signs. So just something to be aware of later down the line. That's where we're taking this. An odd function, on the other hand, would be any situation where the inflection cubic, where an inflection point goes through the x-axis. So maybe it's something that looks like that. Not a perfectly drawn one, but you got the idea. And if I take the integral from negative a to a, we'd be focusing on these areas. And what I would hope that you would recognize is that this function, the above portion, would be equal to the below portion. And if those two portions are equal, as you said earlier yesterday, you should have a net integral of 0. So some examples of problems where we're going to see this and where we're going to use this will be down here. If I have a function that's even and the integral from 0 to 5 of f of x dx is 3, then the integral from negative 5 to 5 is just double 3, because from 0 to 5 is 3, then from negative 5 to 0 is 3. We could say the answer is 6. From negative 5 to 0 is the same from 0 to 5. And from negative 5 to 5 of 4 would be 4 times 6, 24. On the flip side of that, if the integral from f of x is odd and goes from 0 to 5 of f of x dx is 3, if we take the integral from negative 5 to 5 of f of x dx, the above would cancel the below. The reason why that happens is that the integral from negative 5 to 0 would be negative 3 below the x-axis. And if we multiplied the full integral from negative 5 to 5 by 4, well, 4 times 0 is still 0. Now, those are really simple situations where you would be asked to do that. Questions that are probably more accurate to how you would deal with that are here below. So we're going to take a look at these 4, and then I will have you work on your assignment that's attached to this, as well as finishing off your other assignment, and we will take a look at those on Monday. So if f of x is odd, and negative 4 to 7 f of x dx is 5, then the integral from 4 to 7 f of x dx is what? So I know I have a function that's odd. And what that tells me, I want to draw a picture of it. Like I said, drawing pictures, it's a good thing. So I got a function that's odd. Don't know about you, that looks pretty odd to me. I know that from negative 4 to 7, that this whole thing right here is 5. Well, wait a minute. If this is negative 4 to 7 is 5, and this is odd, I know something about from negative 4 to 4. That this region and this region would cancel each other out. The below would cancel out the above, which is going to leave me the region from 4 to 7. And if the negative 4 to 4 canceled each other out, then that would mean that the 4 to 7 is the only spot where we accumulate. Which means if from negative 4 to 7 is 5, then from 4 to 7, our f of x must be. And that's the type of question they're going to ask you. That's why pictures are useful. Drawing the graph, trying to evaluate how things work. Looking at the next one. If f of x is even, and negative 2 to 2 of f of x dx is 4, and negative 5 to 5 of f of x dx is 12, then 2 to 5 of f of x dx is what? All right, I've got an English problem. Wow, an even problem. Looks something like this. That's cool. I tell you that from -2 to 2, that's all 4, which means each one of these segments here has an area of 2. Using the even concept, we can divide that out by 2 for 0 to 2 and -2 to 0. I also tell you that -5 to 5 is 12, which means that each of these whole regions is going to be, I'm going to real quick do the 5s in a different color. Do those in my purple. It's 12, which means each of those is 6 from 0 all the way out. So if this whole region right here is 6, and this little region is 2, then this region must be 4. Using some calculation there. And ladies and gentlemen, the question asked from 2 to 5, you found your answer. Other questions that would require properties would be questions like the one below. If the integral from -5 to 2 of f of x dx equals -17, and the integral from 2 to 5 f of x dx is -4, then the integral from -5 to 5 f of x dx, well, we'd have to realize that if I take the integral from -5 to 2 of f of x dx, and I add to that the integral from 2 to 5 of f of x dx, that should give me my integral from -5 to 5 of f of x dx. I notice that -5 to 2, 2 to 5, okay, cool. This is where they're going to... So what students will do, and I'm going to make a mistake here, so just be ready for this. What students will do is students will say, okay, from -2 to 5 is -17, and from 2 to 5 is -4, and the answer is -21, and they would be wrong. The reason is right here. Compare what I wrote, -5 to 2, 2 to 5, not -5 to 2, 5 to 2. You see that interval, this is what I was talking about earlier, that interval got flipped. So that's not a -4. It's a -4. -13 is your final answer. And last but not least, if the integral from 0 to 3 f of x dx equals 8, and the integral from 2 to 5 of f of x minus 2 plus 2x minus 1 dx is equal to what? Wow. Wow. There's a lot to eat here. So let's get chomping. First thing I want to do is I would like to split this nastiness into little pieces. So the integral from 2 to 5, the f of x minus 2, we'll get to that one in a second, plus the integral from 2 to 5 of 2x dx, plus the integral of -1 dx. You could have also written that as minus. I just didn't write, I wrote a plus, so I want to leave it as that. Oh, oy vey, where do we go from here? I'll tell you what, I'm going to start with the easy one. So I like the easy ones. Easy one right here. We're down 1. Oh, and I didn't go from 2 to 5. There we go. And we're going to go from 2 to 5. So we're going to have a rectangle that's below the x-axis by 1, and its delta x will be 3. This is -1 times 3, which we know eventually will be -3. 2x. Let's deal with 2x. I'm going to do this in blue. If you think about what that graph looks like, this is like what we talked about earlier. Going from 2 to 5. My apologies. So if x is 2, this is going to be a height of 4. And if x is 5, this will be a height of 10. We would have a trapezoid we're dealing with. So that would actually be base 1 plus base 2. This would be the average of my heights times, or the bases times the height, which is 14 divided by 2, that's 7 times 3. So that should be 21. And if I look at this function is shifted to the right 2. So if I shift 0 to 3 of f of x to the right 2, the 0 will become a 2 and the 3 will wait. So just like the last problem, we shifted the function to the right 2, we also shifted the limits of integration to the right 2, which means this has to be an 8. 29 minus 3, 26. Ladies and gentlemen, I hope that all made relatively decent sense. If you have questions, I hope that you will tell them to me on Monday, and I hope that you have a fantastic day. You've got an assignment that's attached to this that you should be able to knock out. You also have the Riemann sum definite integral questions from the graph that you had from yesterday. So you've got plenty of stuff, from yesterday. So you have plenty of stuff to take care of, and I look forward to seeing you. Bye-bye.